Hello everyone, Mr. Minnick's my name, math is my game, and today what I'm doing with my Algebra 2 classes is going over a little bit of prerequisite material. Now, that's material that the students are going to need to know about going into the school year. So, I've broken this down, got a few pages here, a few slides and notes. The first page, it might kind of surprise you. It says math, terms, and motorcycle tests. So let me kind of explain to you about a motorcycle test. At the Eastwood Mall, they have this testing course, and the testing course usually starts right about here and usually finishes right about here, okay? So when I went to take my motorcycle test, I observed some things that totally surprised me. I could not believe them. There's a box right about here and another box right about here, another box here, another box here, another box here, and all kind of boxes and lines. So there's a line here, and then there's cones. There's a cone here, and there's a cone. Oh, I said there's cones. Let me just see if I can draw the cones. Cone, 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 cone. Okay. So when you go to take your motorcycle test, they'll say, okay, start out in this box. So here you are on your motorcycle. There you are. You're happy. You're taking your test. You're all geared up. And the instructor will say, I want you to go around the first cone on the left side. And then I want you to zigzag in and out of the cones. And when you come back, I want you to return in the box next to you and stop the bike and stay stopped without putting your feet down as long as you can. So here's what you'll do. You'll go like this, and you go like this, and you go like this. And some people dump the bike, and then you go like this, and then you come back, and then you stop in the box. Well, if you go the wrong way around the cone at first, they fail you. You don't even get to take the rest of the test. Big deal. Left, right. Who cares? Well, it's a big deal. If you have your right turn signal on, and you make a left-hand turn, you're going to probably likely cause an accident. Okay? So right, left is a big deal. In math, in this class, in Algebra 2, positive or negative, that's a big deal. Okay? So math is precise. Taking a motorcycle test, it's precise. Following directions is a big deal. So what does math have to do with motorcycle tests? It's precise. Math is precise. Taking a motorcycle test is precise. If we had an equation that said x squared minus x plus, let me make that minus 2, equals 0, okay? One thing that test might say to you is this: find the positive solution of the following, of this equation. Okay, so it's a quadratic equation. We'll study those in about 3 or 4 weeks' time in chapter 4. And the directions say find the positive solution of that. A couple things to note. The directions, it's kind of weird. It doesn't say solve. Most of the time when you have an equation, the directions say solve. So what I'm noting here is the directions find the solution. That means solve, okay? But these directions are a little different. It says find the positive solution of. So that should kind of make you raise your eyebrows and say, what is going on? It says find the positive solution. Well, maybe that implies that there's a negative solution? Yeah, maybe it does. Maybe there's a negative solution too. Same equation, x squared minus x minus 2, x squared minus x minus 2, x squared minus x minus 2 equals 0. On a test, you might see that same equation. It'll say solve by graphing. Okay? It'll say solve by graphing. What's that mean? Well, the directions ask you to do something specific. They want you to find the solution or solutions. This time they're not asking for the positive solution. They're asking for you to solve it. True story. True story. FTA. That stands for the fundamental. T stands for theorem. A stands for algebra. It sounds like a really big idea, right? The fundamental theorem of algebra. The reason I'm laughing is this. The fundamental theorem of algebra says an equation has a solution. Let me say that again. An equation has a solution. Well, there's an equation because there's an equal sign. Solve it. Yeah, there's going to be an answer. Solve this one. Yeah, there's going to be an answer. This goes on, though. There is something additional to it in the form of a corollary that's related to this. The corollary says, you know, if it's a x plus 8 equals 7, there's going to be one solution. If it's something like x to the 5th plus blah, blah, blah equals something else, there's going to be 5 solutions. And we'll study this in chapter 5. So the deal is, because this exponent of 2 here, this particular equation does have solutions. In fact, the solutions, there are going to be 2 of them. Okay? This is actually what we call set notation. Set notation. We use, let me get it right, parentheses are the round ones, brackets are the square ones. These are braces. We use braces for set notation, okay? So if the directions ask you to solve this by graphing, and you did this, you said x and x equals 0, you put a 1 here and a 2 here and a minus here and a plus here, and you said x plus 1 equals 0 and x minus 2 equals 0. So you said x equals negative 1 and x equals 2. Did you find the solutions? Yes, you did. Did you solve it? Yes, you did. If we were back on the last page, it says find the positive solution. So the positive solution would be x equals 2. That's the positive solution, right? The positive solution is that x equals 2. So 2 is one of the solutions. But back to this, it says solve by graphing. Did we solve that by graphing? Well, no, we didn't. No, we didn't. If we were to have done that the right way and solved that by graphing, what we would have done is we would have used the Cartesian plane. We would have graphed this particular function, and when we graph it, we'd see that it looks kind of like that, and we would make note that that's the point 2, 0, and this other one's the point negative 1, 0. Okay. So, big deal. I didn't follow the directions. Well, it is a big deal. Math is precise. Motorcycle tests are precise. You got to know right and left. You got to know solve by graphing, solve by factoring, solve by doing something else. Okay? So, suppose we had something that looked like this. It just said radical 36. Okay, that's all it says. Now, most of you would probably be able to answer this question right. You would say 6, and you're right. 6 is right, okay? But there should be some directions with that. The directions might ask you to simplify. And if they asked you to simplify, then 6 is right. 6 is definitely, without a doubt, the right answer. Okay? Good. 6. That's right. Now, on the other hand, if the directions asked you to solve x squared equals 36, and you said 6, well, in that context, I'm not so sure that you'd be right. Well, let's see what happens. We would take a square root, so we would get x equals the square root of 36. And you might say, well, 6 is right, because 6 squared is 36, so 6 is right. Yeah, you're right, 6 is right. But is there another number that when you square it, you get 30? Oh, yeah, negative 6 works too. So the solution would be negative 6 or positive 6. Negative 6 or positive 6 would be the solution set. Well, 6 is right. Well, it's half right. Let's think about a grade scale. Half right. 50%, 50%. Yeah, not doing so good. Okay. So, math terms, solve by graphing, find the positive solution of solve or simplify. Math terms are a big deal, okay? I told the other two classes this morning. The reason people fail at math a lot of times it's not because they can't do math. The reason people struggle with math is because they don't understand the language. Math has a language all of its own. Math terms mean something different than the same word used in a different context. Take, for instance, the word factor. In math, factor means something different than it does in the quote-unquote real world. Factor means some kind of condition. Factor means something a little bit different in other contexts. Factor means, some attribute, something that contributes to something. In mathematics, factor is the same as a divisor. Okay, so math terms. It's real important that when we have notes on a particular section, that you take notes. And the reason we give notes is because there are terms in there. And if you understand the terms, it'll unlock the language. And if you understand the language of math, you'll have a better shot at being successful at math. One final thing before we move on. Think of a German Shepherd dog. You could call a German Shepherd dog till you're blue in the face, and that dog will not come to you if you say, "Come here, boy. Come here. Come here." That dog just looks at you, "I don't know what to do. I don't know what to do." But if you shout that command in the German language, and that dog was trained in the German language, it will be there right now. Math is the same way. It's a language of its own. Get comfortable with it. Don't be afraid of it. Okay. PEMDAS. I'm not a real big fan of this example I have here, but I'll leave it up. It's okay. We'll look at it. PEMDAS. Parentheses first. That's true. No problems with that. Well, there's no parentheses in this expression. Exponents. We do have an exponent of 2 to the second power, so we do have to handle this. So 2 to the second power is 2 times 2, which is 4. Here's the problem I have with PEMDAS and the way it's taught. It kind of looks like we need to multiply and divide. But if you had an expression like this, 8 divided by 4 multiplied by 7, PEMDAS kind of makes it look like, if you follow PEMDAS to a T, PEMDAS makes it look like you have to multiply before you divide, and that's not true. Okay. PEMDAS means you would have to take 4 times 7, which is 28, and then take 8 divided by 28 if you followed PEMDAS. But the deal is, PEMDAS means, when you get to multiplication or division, what you can do with those is you can do those in the order that they appear in. So if we look at 8 divided by 4, 8 divided by 4 is 2. All right? 8 divided by 4 is 2, and 2 times 7 is 14. Okay, kind of interesting. Calculators know PEMDAS. Okay, calculators understand PEMDAS. If you took 8 divided by 4 times 7, there we go, 14. Okay, so this answer here in green is correct. PEMDAS means if you have multiplying and dividing, you do them from left to right as they appear. Bad habits we develop in 7th grade, and in this case it's actually okay. 8 divided by 4 equals times 7 equals. There we actually get the right answer. But if you followed PEMDAS to a T and you took 4 times 7, and that's 28, and then we took 8 divided by 28, well, that's not going to give us 14. Okay, so anyway, back to this problem here. This one's kind of a mess. We're done with the, no, we're not done with the multiplying and dividing. 9 times 3, 27 divided by 5. 27 divided by 5 is a fraction, and I want you to realize something. I want you to realize that fractions are okay. Let me say that again. Fractions are okay. You're really going to have to get in the habit of working with fractions. You're going to have to be comfortable with working with fractions in this class, okay? If we tried to add 4 to 27 fifths, that's not a good idea. So I would multiply 4 by 1. In order to do this, I'm going to multiply 4 by 1, but my 1's going to look a little bit different. I need to turn 4 into some kind of fraction that has fifths in it. Well, 5 divided by 5 is the same thing as 1, so if I multiply by 5 fifths, this 4 is 4 over 1. 4 times 5 is 20, and 1 times 5 is 5. 4 is really the same thing as 20 fifths, and I hope everybody kind of gets what I did there. So that's going to help us handle all that out of it. So we got the 2 squared done, we got all this done. So we still have that 6 hanging around out front. And the 6 also needs to be converted into fifths. So I would multiply by 5 fifths. So that's going to give me 30 fifths. So I've got 30 fifths, 27 more fifths, and then 20 fifths. So I get 57 plus 20, or 77 fifths. Okay, 77 fifths. Now, most calculators here are going to give you a decimal answer. Not a fan of the decimal. I'm not a fan of the decimal. Let's look at the DI Inspire for a second. Great calculator. Great calculator. 6 plus 9 equals, what does it equal? 15. Okay. And then what are we doing? Times 3 divided by 5. So times 3. So times 3 equals, divided by 5 equals plus 2. Whoop, plus 2. Plus 2 equals, and then squared equals. 121's way off base here. Bad 7th grade habits, looking at an expression and going one operation at a time. Really bad. Really bad. That expression that was given, just punch it in right as it appears. The calculator knows PEMDAS. So we had 6 plus 9 times 3 divided by 5 plus 2 squared. If we enter the expression just as it is, the calculator will do the right thing and give us 77 fifths. Okay? All right. Looking at this other version of it, it would have been much nicer if we had this expression to evaluate, because 6 plus 9 is 15. 15 times 3 is 45. And that divided by 5, of course, is 9. 2 squared is 4. And 9 plus 4 is 13. Okay? So PEMDAS. Remember, with PEMDAS, it doesn't necessarily mean you have to multiply before you divide. It just means when you get to multiplying and dividing, you do those from left to right. Okay? All right. Well, moving right along, now we're looking at evaluating expressions. The word evaluate in math class, it means to obtain, to get, to arrive at a numeric answer most of the time. Most of the time. Okay? The underlying process, the steps, the algorithm, the procedure is substitute. Some teachers back in my day used to call it plug and chug. There's variables, you replace variables with numbers. Okay? A common example you might see is this: y equals 2x minus 8. Find y when x is negative 3. Okay? So here's our problem. Here's our expression that we're going to evaluate. We're looking at the expression, a function, y equals 2x minus 8. We're going to find y. When x is negative 3. What's that mean? It means we're going to replace x. It means we're going to replace x with negative 3. So that 2 and the x are next to each other. That's really 2 times x. That's an implicit operation there, 2 times x. So I can't write 2 negative 3. That doesn't make sense. I got to put some parentheses, 2 times negative 3, and then minus 8. So back to PEMDAS, 2 times negative 3, that's negative 6. Negative 6, and then I got that minus 8. Negative 6 take away 8. It's going to give me negative 14. And that's what y equals when x is negative 3. Okay? So that's not so bad. That's not too bad to evaluate. Just make a substitution. Notice our answer is a numeric answer. It's negative 14. What's negative 14? The value of y when x is negative 3. Okay? So Where this gets confusing, and people start to get scared of algebra is this F notation. F notation. Okay? So we might see something like this. F of x is 2x minus 8. Find f of negative 3. Well, I've got news for you. F of x is 2x minus 8 is the same thing. F of x is 2x minus 8. That right there is the same thing as y is 2x minus 8. 2x minus 8, 2x minus 8. Y, f of x. Y, f of x. F of x and y are kind of the same thing. Rather than saying find y when x is negative 3, we say find f of negative 3. So the implication here, what we're going to do is we're going to replace x with negative 3. Okay, so what that looks like is this. 2, negative 3, remember that's an implicit multiplication. 2 times negative 3 minus 8. So we get negative 6 minus 8, and we get negative 14 again. That's our answer. But here's where people get confused. Notice what happens on the left side over here. On the left side, we're finding f of negative 3. So the deal is we've got f of negative 3, and a lot of people don't know what to do with that. What do I do with this f business? What do I do with the negative 3? Do I divide by? No, you don't divide by negative 3. Do I divide by f? No, you don't divide by f. This expression means that the value of the function f, the value of the function is negative 14 whenever x is negative 3. Okay? So f notation, evaluating, we're going to study f notation a little bit more next week when we get into functions and testing whether a relation is a function. And then again in chapter 5 and 6, we're gonna use f notation quite a bit. So it's one of those things you gotta get used to it. Okay. Solving equations. What I want to say about solving equations is a couple things. Number one, I'm not going to ask you to show every single step of your work in solving an equation. If we had 3x minus 9 plus 4x minus 8 plus 6x equals a negative 2x plus 5. Okay? I don't expect you to take up 3 sheets of notebook paper to solve that. Okay? So maybe you're using a colored pencil, a highlighter, something like that, and you highlight this 3x, this 4x, and this 6x, and so what you do is you realize 3x and 4x gives me 7x, and 7x and 6x gives me a total of 13x, and you just go right to that. I'm good with that, okay? I'm not your 9th grade algebra teacher. I don't need to see you, kind of go through this process. 3x plus 4x plus 6x minus 9 minus 8 equals 2x, negative 2x plus 5. Now, if you want to do that, fine. I don't have a problem with that. But what I'm saying is I don't need to see all that work, okay? Showing work is good, and having the discernment of how much work to show is going to be kind of a sticky subject. You want to show some, but you don't need to show all your work, okay? I'm not asking that. I'm not requiring that of you. If you feel comfortable doing it, by all means, show work. So the negative 9 and the negative 8, that's going to give me what? Minus 17. On the right side, there's really not much going on there. So now at this point, I might say, and this is how I solve equations, I'm combining those two terms there. So I'm thinking of this, I'm bringing this negative 2x over, so that's going to give me 15x. This negative 17, I'm going to bring it over here. When I do, it's going to be plus 17, so I get 15x is 22. And so I get x equals. Now, a lot of you like fractions, okay? Or don't like fractions, I'm sorry. I love fractions. There's nothing wrong with fractions. There's nothing wrong with improper fractions, okay? So we get 22 divided by 15. Now that's 1 7/15. That's a little bit smaller than 1 1/2. Okay. And the cool thing about this, I don't know if you're familiar with the TI Inspire. We'll use them a lot this year. You can actually have the Inspire solve this. We say nsolve. Nsolve the equation. Hopefully I get the equation right. 3x minus 9 plus 4x. 3x minus 9 plus 4x. Minus 8 plus 6x. Minus 8 plus 6x. Equals negative 2x plus 5. Negative 2x plus 5. Now, the calculator tells me, you didn't do this right. Well, it will solve the equation. The calculator will solve. But what I've got to know is I got to tell the calculator to solve for a certain variable. What variable? X. And when I do that, 1.46666666667. I wonder what 22 divided by 15 happens to be. I said, I wonder what 22 divided by 15 happens to be. Oh, it's the same thing. Okay, there we go. So again, the solving equations, I don't need to see all your work shown. Okay, the calculator, I don't want you to rely too heavily on it because there are times where it's not right, and we'll get into that in a minute. Okay, so here we go. Good definitions. I love this one question. We got a number cube, all right? Some people call it dice. Dice is the plural. We'd have to have two or more of them. So it's really, if there's one of them, it's called a die, D-I-E, or I call it a number cube just because people don't understand when I say die, they think I'm being mean, whatever. Anyway, if you think about what's possible, you could have a 1 show, right? You could have a 2 show. You could have 3. I think 3 goes like that across, right? You could have a 4. Maybe I should have written these out as numbers. 5 and 6 is my favorite. So anyway, I ask this question: what's P of prime? Now, in this context, this word P means probability. So the question is really saying, find the probability of a prime number showing up when you roll, if you roll a fair die, if you roll a fair number cube. What's the probability that we get something prime? So one of the classes today, somebody said 3. Well, 3, I understand where they came up with 3, but 3 is not the right answer. And it's not the right answer because that person forgot what probability means. We define probability when we study it. Probability is the likelihood that something occurs. Probability is the chance of some event occurring, right? The chance of something happening. And we use P to represent it. Now, something might not happen at all, and if it's not going to happen, it has a probability that's equal to 0. There's no chance that it's going to happen. We actually call that an impossible event. Some things are guaranteed to happen, and their probability, their likelihood is 100%. Probability can be a decimal, a percent, a ratio, a fraction, but 100% is 1. So probability's got to be somewhere between 0 and 1. So that student that said 3, that's way too big of an answer. So then somebody might realize, well, there's 6 things here. So probability is going to be something out of 6. It's the chance that it happens. They're right. It's something out of 6. So that student that said, well, it's 3, maybe they meant to say it's 3 out of 6, or 1/2, or 0.5, or 50%. Maybe that's the right answer. Or maybe it's not the right answer. Maybe there's 4 of these that are prime. In that case, it'd be 2/3. In that case, it would be 0.6 repeating, or 67 and 2/3%, or 66. Why did I get 67? 66 and 2/3%. Okay. So notice the heading of this page. It says the importance of good definitions. One of those answers is right. It's either 1/2 or 2/3. So the question's asking us about prime numbers, and do we know what a prime number is? If we do, then that's good, and if we don't, well, that's not good. You probably remember your 6th grade teacher telling you that a prime number is divisible by 1 in itself. A number divisible by 1 in itself. So if you think about 6, 6 is divisible by 1 and 6 and 2 and 3. So 6 isn't prime. And you're right, 6 is not prime. You think, well, 4 is divisible by 1 and 2 and 4, so it's not prime. Well, you're right. A prime number is a number divisible by 1 and itself. So of the remaining things, there's either 3 or 4. So the question, the focus comes down to, I think we all know, I'm pretty sure we all know, that 3 is prime, well, 5 and 3 are prime, and that 2 is prime, right? But no, evens aren't prime, are they? Well, maybe they are. 2 is only divisible by 1 and 2. 2 is actually the only even prime. So the question boils down to, is 1 prime? Well, I've got news for you. If you don't know the right definition of a prime number, you're not going to be able to answer this question safely. See, in math, some students think that we put definitions on the board to fill in 51 minutes of class. That's not the case. We put definitions on the board because they're important. Because you need to know them to be able to apply them in context later on to make sense of things. And your 6th grade teacher, when they told you that a prime number is a number only divisible by 1 in itself, they were right, but they left out one detail. A prime number is any number larger than 1. A prime number is any number larger than 1, whose only divisors are 1 in the number itself. So 1 is actually not prime. So the right answer here, the correct answer here is 1/2, 3 out of 6, 0.5, 50%. Okay? So the deal is you really need to know good definitions for things. Okay? All right. The calculator isn't always right. Let's think about squaring -1. Squaring -1 means taking -1 and multiplying it by itself twice. So it's -1 times -1. Well, from 7th grade, you remember that the product of 2 negatives is positive. So it should be 1 times 1, which is 1, and it should be positive 1. So if we take the calculator, which is fully capable of squaring something, and we try to square -1, let's see what happens. Let's see what happens. My calculator's not helping me here. Here we go. So I'm going to take the number -1 and I'm going to square it. -1 and I square it. And I get -1, which is wrong. You forgot the parenthesis? Well, yeah, I forgot the parenthesis. You're right. I forgot the parenthesis. Okay, without that parenthesis, the calculator's taking 1. It's doing PEMDAS. The calculator's taking 1 and squaring 1, and 1 squared is 1. And then it's taking the opposite of 1, which is -1. So the calculator's not always right. Okay, I'll show you another instance in which the calculator is not always right. And this one, it's kind of unfortunate because there's going to be a section where we study graphing cube root functions, okay? The cube root of x. And right before that, we're going to learn about complex numbers, okay? So a cube root function, it's kind of interesting, the graph of it. If I think about 1, the number 1, the cube root of 1 is 1 because 1 times 1 times 1 is 1. So this particular function, it's going to go through the point 1, 1. If I think about the number 8, 8's cube root, what number could I multiply by itself, not once, not twice, but 3 times to get the number 8? So here's my x-axis, y-axis. What number could I multiply by itself 3 times to get the number 8? Well, 2 times 2 times 2 is 8. So this graph actually goes to the point 1, 1, 8, 2. The cube root of 0, what number could I multiply by itself 3 times to get 0? 0. This graph goes to the point 0, 0. Okay? So part of the graph looks like this. Okay? So I guess there's a question that comes up. What happens here? What happens here when x is negative 1, or when y is negative 1? Is there some number that I could multiply by itself 3 times to get negative 1? Is there some number I could multiply by itself 3 times to get negative 1? Well, negative 1 times negative 1 times negative 1 is negative 1. So yeah, there is. There is a number. So yeah, that. And then negative 8, negative 2 would work too. So the deal is this function, when we graph it, this function looks like that. Now let me go over that with a highlighter. That function does that. Legitimately, truly, fairly. So let's graph that function on the calculator. Doc. I said, Doc, I need to turn off my smart ink. Clear ink. Okay. Maybe I'll go to the computer here. So I want to go to Doc. I'm going to insert a graph page, and I want to graph the third root of x. Remember, the whole point here is that the calculator is not always right. Look at that calculator graph. The calculator just graphed part of this. It graphed that side of it, but it left the other side entirely out. The calculator is not always right. If I went home on my calculator and you're thinking, well, the calculator's got to be right. Yeah, it does. So what I'd have to do to fix that, to correct that, is on the calculator, I would have to go to the home screen. I'd have to go into the settings of the calculator. I'd have to go into the document settings, and I'd have to change the calculator to only deal with real numbers. And then I'd go back into the current document, and now it graphs it right. The point is, there's going to be some times where we put stuff into the calculator and it's not going to give us the right answer. Okay, so don't rely solely upon the calculator. Okay, it's great, it's an awesome tool, it's terrific, but it's not always right. Cartesian plane. The reason I call it that is because that's what it is truly called. A lot of people call it the XY axes or whatever else. I like to call it the Cartesian plane because of giving credit to who designed it, who gave it its practicality. A mathematician by the name of René Descartes. René Descartes. Okay, René Descartes. That's why it's called the Cartesian plane. Anyway, you'll remember, of course, our independent horizontal axis is the x-axis. We should have arrows on the ends there because that does extend forever and forever. And then there's the dependent. There's the dependent or the vertical axis or the y-axis. Okay. And then there's a couple of quadrants. I'm assuming you know all this. If you don't, take notes on it, write them down. I will be calling out quadrants. I do expect you to know that, of course, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I always mess those up. I know everybody always says that. But that's how it goes. 1, 2, 3, and 4. Remember your S-I-G-N-S, your signs. Quadrant 1, the x and the y are both positive. Quadrant 2, the x's are negative, the y's are positive. Quadrant 3, x and y are both negative. Quadrant 4, x is positive, y is negative. Remember, coordinates are of the form x comma y. So if we had something over yonder, like down here, that would have an x coordinate of -9 and a y coordinate of -7. I said -9, -7. So that's -9, -7. Okay. One final thing I want to say about this is right here. Some people have the wrong idea about that. On a graph, they see an O. That O doesn't mean 0. That O stands for something else. That O is actually the name of that particular point. The coordinates there, of course, x and y both have coordinates there of 0 and 0 respectively. But that O stands for origin, so don't ever get that twisted. Okay? Cartesian plane, there we go. Mathway. By this stage of the game, you probably realized Mathway didn't help so much with geometry. With Algebra 2, does it help? Sure it helps. Will it get you the answer? Sure it'll get you the answer. Is it a useful tool? Yes, if used properly. Let's look at that equation we had earlier. What was it? X squared. X squared. Where was it? Going way back. Minus x minus 2. X squared minus x minus 2. X squared minus x minus 2 equals 0. So Mathway is very intuitive. What I mean by that is Mathway knows more than some of you know you should know about math. I'm not insulting your intelligence. I'm not saying you're idiots. But what I'm saying is Mathway knows what you're probably supposed to do before you know what you're probably supposed to do. So if you punch in a quadratic expression into Mathway, if you type in to Mathway something like x squared, come on Mathway, I got it. Fine. If you type in x squared minus x minus 2, before you even get to 0 in, Mathway's going to think and say, hey, what do you want to do? Mathway's going to say, what is it that you want me to do with this expression? It looks like Mathway's changed a little bit. Mathway, what do you want to do? Do you want to factor? Do you want to simplify? Do you want to apply the quadratic formula, find the vertex, graph, find the x and y intercept? So you need to know the directions. Equals 0. What do we want to do? Do we want to solve by completing the square? Do we want to solve by factoring? Do we want to solve for x? So if we said solve by factoring, Mathway will give us the answers, but it doesn't show us how to solve by factoring. It gives us the answers, but it didn't show us how to solve by factoring. It kind of tells us how, but it didn't show us. And if we want it to show us, then we got to pay money. Mathway, it's good, it's bad. Don't rely solely on Mathway. I think we got 2 more things. Rote learning. No, that's not a typo. No, I did not misspell that. That's simply memorization. It works. Okay, we did it back when I was in school. It works. I'm going to ask you to memorize perfect squares. 1 squared is 1. 2 squared is 4. 3 squared is 9. All the way up to 20 squared, which is 400. Now, you probably already know most of them, but the ones in the middle, 13, 14, 15, maybe 12, maybe 11, you probably don't know. How could you memorize them? Rote learning, repetition, over and over and over. And that's why we do homework. That's why we have problems. That's why I have Math Excel and homework problems, okay? One final thing, WD-40. I love it. Great stuff. Comes in a can. It was put there by a man in a factory downtown. Maybe not a man. Maybe a woman bottled it. But anyway, WD-40. A lot of people don't know what the 40 stands for. They don't know what the W stands for. W stands for water. The D in WD stands for water displacement. A lot of people don't know that you can put WD-40 on your fishing lures and it attracts fish because it has fish oil in it. A lot of people think that there's 40 ingredients to WD-40, and that's a fallacy. That's a lie. That's not true. 40 tries to get it right. It took the makers of WD-40 40 attempts to get the perfect formula. If it took them 41, it would have been WD-41, but on the 40th try, they got it right. So if you mess up, when you mess up, don't think it's the end of the world. You're going to mess up, okay? Please don't hesitate to ask questions. I love them. I learn more from your questions than anything else. So ask questions. I hope everybody has an awesome day. I hope this has been informative, educational, and I'll see you next time. Have a great day. Good.